Here we are for part 2 of our trilogy to create a small touchpad with built-in gesture recognition on an MCU. The MCU we selected is the SAM-L10. The code configurator for the SAM-L10 is start. You will find start on the web, microchip.com/start. We create a new project. We talk about the SAM-L10 here, so this is what we put in search. We see all the packages available, and here we have the Xplained Pro board from the SAM-L10 we selected earlier. Here we are. Now, it's not about writing touch code from scratch. It's about configuring a library for doing exactly that. So what we need to add to our project is the touch library. That's done with 2 clicks. Just search for touch, find the library, and add. Now the rest is configuring of our touch library. We know this is all about a touchpad. So we won't need buttons, we won't need sliders, we won't need wheels. We want to do a touchpad. As we learned in video 1, we have a 5x5 matrix. And for the purpose of the video, I want to show you everything. So we go for 1 and 2 finger gestures. With the sensor configures, we get some info what happened. So we will use some hardware resources of the chip, like the PTC, the peripheral touch controller. That is expected as we are going here for a small touchpad. The UART module is also involved. We will use UART to stream out our data and to visualize with our 2D touch surface GUI. And we need some timeout resources. That's all okay for us, and we proceed. So far, we told the system we want to do a 5x5 touchpad. Now the question is, okay, here's your 5x5 touchpad. Which pin is connected to which channel? That is homework which will be very easy for you as you have created your own schematic. It's just looking into schematic and telling the system which sensor, which X, which Y line is connected to which pin. Furthermore, Driven Shield. Driven Shield is a technology developed by Microchip which allows you for a higher noise performance and water-tolerant touch. You can also apply this to the touchpads, and it's highly recommended. Envision your customer has a wet finger and you want to use a touchpad. Driven Shield technology will enable exactly that. Here we are. On the debug side, I said before, we want to visualize what our touchpad is doing. Therefore, we have a utility, our 2D touch surface GUI, which you can directly download here. The only thing what we need to connect our chip with that utility is UART communication. So we will have to tell the system where are the UART pin, where is the TX and the RX in our PCB. On the parameter side for the touch sensors, we can leave everything to standard. The only thing I would like to show you is you are requested to tell the system what type of gestures do you need for your use case. Like when you need tap gestures, tap or double tap, all these gestures will have a timeout, will have a precision, how big is the tap area, double tap needs to be performed in, and so on. So the more gestures you enable, I will enable everything here. For every gesture you get detailed parameters. If they are unclear from naming, you just go to these question marks and you get immediate help. That's basically all we needed to do. There will be some notifications like telling us again what hardware resources we need. And then there is a summary of our project. This is what we configured. These are the firmware modules which we are using. That's all there is to it. What remains for us is to export that project. We want to continue in Studio, so this is already selected, and we give it a nice name, and off we go. From here we continue in Studio. In Studio we can readily import the pack created by Start. The Solution Explorer will show us all the files created, including the touch files which represent the settings we set in start for our 2D touchpad. Now, a quick look at the main.c will reveal that our main loop is still empty, as it always is when you start a code configurator. We need to add one line of code, which is our touch process. Here we are. That's literally all there is to do. The rest is building the project, as our configuration includes all the settings for touch as well as the settings for streaming out the data towards our visualization GUI. And here we are. The build is done, succeeded. The rest what we need to do is programming the connected Xplained Pro board with tools and device programming. The system automatically detected the connected Xplained Pro. We happily accept that. The memories we just created is a 2D touch hex file, program, and done.